Welcome to wpi.edu/listen, your go-to audio news and podcasts for all things Worcester Polytechnic Institute. After you've listened in, check out our other episodes and dive deep into the exciting news stories shaping the WPI community. Tuesday, August 26, 2025. Q&A with Christina Bailey-Hytholt. Bailey-Hytholt, who discovered her love of research while a student at WPI, now leads a lab focused on women's unmet health needs. Christina Bailey-Hytholt's research explores something so ordinary that it is often discarded when no longer needed, yet so critical that it sustains life. The placenta. Recently named to the Leonard P. Kinnicutt Professorship, Bailey-Hytholt, 15, is an assistant professor in the Department of Chemical Engineering who focuses on using engineering approaches to advance women's and prenatal health. She concentrates specifically on problems of the placenta, a temporary organ that forms in the uterus during pregnancy, to provide nutrients and oxygen to a developing baby. Some of her work is considered exploratory, but she's also interested in developing models of the placenta for research and developing particles that package and deliver therapies to patients. Her research has captured attention from funders and others. In 2024, Bailey-Hytholt was awarded a 3-year, $502,999 National Science Foundation (NSF) grant for early career researchers to determine the relationship between placental cells known as trophoblasts and the biomolecules they secrete, called exosomes, that are important for cell communication. In 2022, Forbes named her to its 30 Under 30 Class of Innovators. Bailey-Hytholt joined the WPI faculty in 2022 after receiving her PhD in biomedical engineering at Brown University and completing postdoctoral research in genomic medicine and biologics drug product development and manufacturing at Sanofi. Her research has been supported by the NSF, the Massachusetts Life Sciences Center, and the Amnion Foundation. She is affiliated with WPI's Department of Biomedical Engineering. The following is a question and answer conversation with Bailey-Hytholt. Question: Did you always want to be a researcher? Answer: I always gravitated toward healthcare. During middle and high school, I volunteered at a nursing home for several years. When I arrived at WPI as an undergraduate in chemical engineering, I thought I would later go to medical school. Then I worked in the lab of Terry Camusano, Dean of Graduate Studies, and had the best experience. She and the graduate students working in her lab encouraged me to think about pursuing research and my PhD. I didn't know what graduate school and becoming a researcher really was until my experience working in a lab. At the same time, I had some health challenges of my own. I realized that there are many things we don't have answers to in a clinical setting, and new research is important to advance medicine. Question: How did you decide to focus your research on women's unmet health needs? Answer: Women's health is an area that I can relate to and feel I can be an advocate for, which led to my passion for this area of research. However, research into women's health as an engineer really wasn't on my radar until a few things came together during my first year of graduate school: opportunities, exciting projects, and good mentors. There was an opportunity to contribute to a prenatal diagnostic project, and that project spurred ideas about using engineering skill sets to study the placenta. I also was fortunate to be an NSF fellow and to have advisors who supported me. Pursuing these projects, I really became passionate about the subject and saw that there were not many engineering approaches being used to advance prenatal and women's health. On a personal level, I recently went through my own pregnancy and had a healthy daughter, so I saw firsthand how important research is for prenatal health. Question: What does chemical engineering have to do with human health? Answer: The words chemical engineering may typically conjure up images of a person wearing a hard hat and working in an industrial plant, but chemical engineers work in many different fields. Many chemical engineers work in health-related fields, such as the pharmaceutical and biotechnology industries. Chemical engineers learn to solve problems involving complex systems and processes, and human health involves complex systems and processes. Chemical engineering concepts such as material properties, mass balances, transport, kinetics, thermodynamics, and more are crucial to designing therapeutics and cell models, which are important in advancing human health. Question: what is the goal of your 3-year NSF-funded project? Answer: the goal of this project is to study and identify the relationship between the environment that trophoblast cells, the main cells in the placenta, are grown in and how they communicate with each other. Trophoblasts invade the endometrium, which is the membrane that lines the uterus, to anchor the placenta in place and ensure adequate blood flow. Trophoblasts also secrete factors that allow cells in the placenta to communicate with each other. The placenta is not a well-understood organ, so my lab is looking at how the environment in the placenta, such as the presence of growth factors or hormones, influences invasiveness and impacts what trophoblasts secrete. It's important to expand knowledge about the placenta because it is a critical organ for developing babies, and there are studies that suggest placental health impacts the lifelong health of babies and mothers, so really everyone. This award also financially supports graduate and undergraduate students in the lab. We have a great team working on this important project. Question: as a graduate of WPI, what is it like to return here as a faculty member? Answer: I love it. It's awesome to be back in the same research building where I got started. I also think a lot about the mentors I had as an undergraduate, how they influenced my career decisions, and how I can give the undergraduates in my research group a similar experience. I want to give them the opportunity to own their research and enjoy an immersive experience. In the classroom, I can relate to students taking the chemical engineering courses that I teach, because I was in the same seat as them not so long ago. I thought the 7-week terms were fast-paced as a student, but they seem to fly by even faster now as a faculty member.